Welcome to my video on box and whisker plots. So box and whisker plots are used to describe how spread out the data is. And it gives you a good impression of the shape, center, and spread of the data. However, it doesn't show a distribution in as much detail as maybe a stem and leaf plot or a histogram would. But it allows you to quickly analyze a set of data um, by identifying key statistical measures such as median and range. And there will be 5 critical points in a box and whisker plot, which is typically known as the 5-number summary, and we'll go over that as we go through this note sheet. So we have it split up into quartiles, and the data is split into 4 equal parts. Okay, and they're called quartiles because this is each part here is going to represent 25% of the data. So from this endpoint to the beginning of the box is 25%. From the beginning of the box to the middle here, which this is going to be known as the median here, is 25%. From the middle of the box to the end of the box here is another 25%. And lastly, from the end of the box to this endpoint here is 25% of the data. Okay, so this beginning part of the box and whisker plot, so you can see why it's called box and whisker plot. We have the box, and then we have the whiskers on each end here. So this beginning part here is called the lower extreme, and you can see it's at 16. And this represents, as you can see, the smallest number in the data set. Okay, the beginning of the box here, you'll notice, starts at 18. And we call this the lower quartile. And we'll go into more detail in just a minute down here in the summary of terms. Okay. This part here is the middle, which is known as the median, and you can see it's at 22. So let's label this the median. And then we have the end of the box. So we're going to call this the upper quartile. And I forgot to point out this is at 26. And then finally, the very end point of the box here is called the upper extreme. And this is just the largest number in the data set. So let's come down here to the terms here. We have the first term here, we have the lower extreme. And we said that's the smallest number in the data set. We also call that the minimum. Okay, so this is the lower extreme here. Then we had the upper extreme, which is the largest number in the data set, which we also call the maximum. All right. Then we have the median, which is the middle number when ordered from least to greatest. So it's the inside of the box. So if you look up at our picture, it cuts the box vertically, okay, right down the center, or right down the box. Not necessarily the center of the box, not like it's not necessarily the same on each size, like the same length. And then we have the lower quartile is the median. Let's box this in of the lower half of data set, and that's the beginning of the box up here, okay, which was 18. And then the upper quartile is the median of the upper half of the data set, which was the end of the box. Okay, and let's look at the questions below here. It says, use the box and whisker plot below summarizing bowling scores for 19 students to answer questions 56 and 57. So it says, which score represents the median score? So if I look at this, I know that this is the lower extreme. The beginning of the box is the upper quartile, or sorry, the lower quartile. The end of the box is the upper quartile, and this is the upper extreme. So if I'm looking for the median, I want to know where it cuts the box. So it's right here. So that would be C, 143. But for some reason, the answer choice here is H, 143. Okay. Number 57, what percent of the students bowled between 81 and 162? So please draw this diagram. I'm just going to sketch this out so we can see this here. So this is my lower extreme, which is 81. And then we have the box here, and the upper quartile, or the lower quartile, was 105. The median was 143. The upper quartile is 162, and then completing my whisker here is the upper extreme at 219. Okay, and we know that we have 4 equal parts here in terms of percentage. So this is 25% of the data, and then this is another 25% of the data, and this is another 25% of the data. And so we wanted to know from 81 to 162, which is right here. So if I add these percentages up, 25 plus 25 plus 25, that means 75% of the data is from 81 to 162. Okay, so if there were 20 scores, then 15 of the scores would be in between here, because 15 is 75% of 20. Okay. All right, let's look at the back side here, and we're only going to answer 20 and 21 here, and then we'll come back to 22 and 23. So it says, which data set contains the least value? So we look here, and we're going to look at the lower extremes, and so I can clearly see that B has the smallest value, because this is 20 and this is about 25 for A. So we're going to put B. Okay, number 21. Which set of data contains the greatest value? So I'm looking here and here. I'm looking at the upper extremes, and you can clearly see the answer is B again, because it's at 70 and this one is at about 65. All right, we'll come back to 22 and 23 when we finish to the bottom of the note sheet. So let's look at how to draw a box and whisker plot. So we have calories in 1 cup serving of fruit. So we have our fruits here, and we have our calories. Okay, so what we're going to do here is we are going, whoops, that is not what I was trying to do. Trying to shrink the screen here so we can see it all at once here. We can see most of it. So the first thing we have to do in a box and whisker plot is plot the smallest value in the data set. Okay, so we're looking for the lower extreme. Okay, so we have to look at the data set and find the smallest number, which of course is going to be 45. So we're going to make a mark at 45, and we're going to have to do the best we can here because the numbers are really hard to see. So we want to go right in between 40 and 50 and put a dot above the number line. Okay, now the second step is to plot the largest value in the data set, which is the upper extreme. So the largest number, so we're going to come up here and look for the largest number, and I see that it's 113. So we're going to come right about here and make a dot. Now, we have to order the numbers from least to greatest because now we're going to find three medians. We're going to find the median, and then we're going to find the lower quartile, which is the median of the lower half, and then we're going to find the upper quartile, which is the median of the upper half. So I need to go through this, and I know I have 45 is the smallest, and now the next smallest is 69, so I can cross that out. And it's helpful to cross them out as you go, and that way you don't miss a number. 73, and then 81, and then 84, and then I see another 84, and then 90, and then finally 113. And I crossed them all out, so I know I used them all. So now we have to find the median of the data set and plot it on the number line. So we're going to cross out one from each end. And we notice there are two in the middle here. So when there's two in the middle, we have to find the average of the two numbers in the middle. So we're going to add them up. So we're going to do over here, you can do 81 plus 84, oops, divided by 2. Now when you add these up, make sure you hit equals before you divide by 2. So this equals 165 after I hit equals, and then I divide by 2 and I get 82.5. Okay, so I'm going to come up here to about 82 and a half, right about there. And that's my median. Now we're going to split the data in half. Okay. So remember, this is where my median was. So we're going to look at the median of the lower half, so to the left of the median. So my median's right here at 82.5. So we're going to look at the median of this lower half. So I'm going to cross out one from each end. And let's go ahead. Step 6. This is the lower quartile. Now let's go up here and find the median of the lower half. So cross out one from each end. And notice, once again, I have 2 in the middle. So we're going to add them up. 69 plus 73. And remember, we have to hit equals before we divide by 2. So when I hit equals, I get 142. And I divide by 2, and I get 71. So we're going to come up here and make a dot at 71. Okay. Now we're going to find the median of the upper half, which is called the upper quartile. And then we're going to plot it. So remember, our median was 82.5, so we're going to go the median to the right of the median. So we're going to cross out one number from each end. And notice, once again, we have 2 in the middle. So we have to find the median of 84 and 90. So we're going to add them up. 84 plus 90. And remember, when I type this into my calculator, I'm going to hit equals, and that gives me 174. and I'm going to divide by 2, and I get 87. So I'm going to come up here and make a dot at 87 right there. Okay, and now we box up the lower quartile, the median, and the lower quartile median, the upper quartile median, and the median. So we're going to box this up. And then remember, the median makes a vertical line. Okay, and then we're going to draw our whiskers to the lower extreme. Right here. And then we're going to draw our whisker to the upper extreme. And remember that each section here is 25%. So this is 25% of the data, 25%, 25%, and 25%. Now, sometimes you will be asked to compare the data. So we'll look at the ranges. So the range, remember, is the largest number minus the smallest number. And we already figured those out. The upper extreme basically minus the lower extreme. So the upper extreme was 113. The lower extreme, or the smallest number, was 45. And that will equal 68. Okay, now the inner quartile range of the data set is just how it sounds. It's the range of the quartiles. So the range of the box. So it's the upper quartile, and I'm going to use UQ, minus the lower quartile, LQ. So I'm just going to abbreviate there. You'll often see these abbreviations from time to time. So the upper quartile, which was the end of the box, was 87, and minus the lower quartile, which was the beginning of the box, was 71, and 87 minus 71 is 16. So the inner quartile range would be 16. Now let's go back to those two questions from earlier, because I wanted to draw the box and whisker plot before we talked about these questions. So now that we know what they are, which set of data has the greatest inner quartile range? So we're going to be figuring out the upper quartile minus the lower quartile. So let's abbreviate here. So we're going to do the IQR, which is the inner quartile range of A. So let's figure that out first. So I see that the upper quartile is 60. The lower quartile is 30. So I'm going to do 60 minus 30, which gives me 30. And we'll do the IQR of B. So I'm looking for which one's the greatest. 60 minus 40 is 20. So you can clearly see A has the greatest inner quartile range. Now, look at B. Okay, I can already tell, look at A and B. Which set of data has the greatest range? I can already tell it's B. I kind of gave that away. And here's how I can tell it's B. I know that B has the greatest number and the smallest number, so that's going to have the biggest range. 70 minus 20 is 50. And if I look at A, it's about 65, and the lower extreme is about 25, so 65 minus 25 is 40. So clearly 50 is bigger than 40. So just remember, inner quartile range, you're subtracting the upper quartile, or the end of the box, minus the lower quartile, or the beginning of the box. And the range is the upper extreme, or the biggest number, minus the smallest number. So remember to keep those straight, because it's easy to confuse those. That concludes our notes on box and whisker plots. I hope you have a great day.